Good morning, everybody. My name is David Sutton, and I'm the host for this first session today. Following the injunction that we should introduce ourselves, I should just say that I am the treasurer of the Oxford Symposium, which brings a number of responsibilities with it, some of them very pleasant indeed. And those of you who've won awards, the Young Student Awards, need to be in touch with me before the end of tomorrow in order that I can transfer your winnings to you. So that's absolutely the nicest part of being the treasurer of the Oxford Symposium. So just note what I look like and come and chase me at some stage in the next 2 days, and I will pay your awards to you. This session is entitled The Svalbard Global Seed Vault, Noah's Ark for Seeds in the Arctic. And our guest speaker will be Dr. Åsmund Asdal, and I'll be introducing him in just a little while. As a warm-up and an introduction to this session's theme, we're first going to show a brief film which is about the transfer or the travel of seeds to the seed vault. So if we could set up the film and play that first, please.
They're down.
Llaqtachaymantas wiltaramusqani, wasichaymantas puririramuni. Pachamamama paguta ruwaspa, apukunaman nuqamañamusaq. Kay karu llaqtapi qantiyanakipaq, kay karu llaqtapi qantiyanakipaq. Imanispataq kutirapusaqri, hayk'anispataq kutirapusaqri. Kay karu llaqtaman papachayta saqi, kay karu llaqtaman papachay pasampun. Imanispataq kutirapusaqri, hayk'anispataq kutirapusaqri. Kay karu llaqtaman papachay pasampun. Pachamamama paguta ruwaspa, apukunaman nuqamañamusaq. Kay karu llaqtapi qantiyanakipaq, Imanispataq kutirapusaq.
El Parque de la Papa es una asociación de 5 comunidades indígenas o andinas. Es una área de conservación de agrobiodiversidad de papas nativas pues también ahí se está conservándose todo nuestro conocimiento tradicional y todas nuestras culturas vivas, y también llamado como un patrimonio biocultural e indígena. Es un paisaje cultural, ¿no?
¿Por qué un parque de la papa? No es solamente mantener una gran diversidad genética, pero también la historia de nuestro pueblo. Esta coevolución entre los quechuas y la papa nativa hace posible que nuevas expresiones genéticas puedan surgir y que estas otras que existen puedan seguir adaptándose a estos cambios que en los Andes se ven y que son dramáticos. El cambio climático no es un fenómeno simple, se necesita ver cómo se puede crear la alimentación del futuro. Pensamos hacer este viaje a Svalbard, donde una comisión del Parque de la Papa llevará las semillas, porque esto no se puede responder solos.
Pachamunasqay saqiya pushani. Nishkaro kasi nchira atrás ashrik katara jibang na atrás tagish. Ya bini. Nada kuchillo de man ya hampa nicha.
Preserve the seeds here is that we want them to serve the farmers in the future. Get back to face the challenge that we have in the future. For FAO, this is what matters. Bring farmers and scientists together to preserve biodiversity for future generations. Use that in their benefit.
It's 120 meters now from the entrance and until we enter the mountain. Then we go through a tunnel which is also outside the mountain, and then we enter the mountain and enter a door and come into where it's -6 degrees all year around because of the permafrost. So let's go. Let's go.
Most important that is having the farmers here bringing potato. Potato is one of the 5 big crops in the world that feed around 75-80% of the population nowadays. In situ preservation, what you do, the new varieties that you have been growing, up to 5,000. This is really part of the challenge that we have for the future, have those varieties available to be used in the future. To use those genes for bring resistance to other possible varieties. So we thank you.
I've been talking to my colleagues here, and we have very strong and mixed emotions. This for us is a true spiritual journey. The potato's history goes back to the beginning of time for us. All our culture have evolved, co-evolved with the potato. We are potato people. We have it when we are born, when we get married, when we get baptized, and they grow very close to us, that they are part of the family. And we've been talking about how this part of us, this family of us, is going to stay here. And there are our mixed emotions, because we're not just living genes or tribes, but also a family.
Mamakocha kay llaqtapi sumaqta kan qawarinki kay tukuy muhukunata qipawiñaykunaq mikunanpaq kay montaña kasqa sumaq riq'imama qanya sumaqta cuidanki waqaychanki kay muhunchikkunata Perú suyupi awsangati itusiray hatun nuqaykuq kanki yanapaqni apuyku qanya munayta kayta uywanki qhawarimunki kunanqa makiykiman hap'ichiykikuq kay mukhuykuta nuqaykupaq mihunaykupaq qipa wawakunaq mikunanpaq hina qipanmantaq munduntin runakunaman mihuchinaykipaq chayrayku nuqayku kayta apariykiku kaywan tukurikamunkiku tukuy sunquykuman.
Llaqtachallaymantas nuqa hamurani wasichallaymantas nuqa hamurani Chayayqipiqa Svalbard llaqta Urquntapas wasaparamuni mamakuchata alqunta qhawa
in this way. Okay.
Peru to Norway. Wasn't that wonderful and also very moving? It's my pleasant duty now to introduce formally the keynote speaker for this morning, Dr. Åsmund Asdal. And the formal, I think possibly the reason that I've been asked to do this is that I'm a professional archivist, and as an archivist of documents in my profession, I can tell you that we also regard Dr. Asdal as an archivist, but an archivist of seeds. So the formal introduction reads as follows. Dr. Asdal, biologist and agronomist, works at the Nordic Genetic Resource Centre as coordinator of the Svalbard Global Seed Vault. Dr. Asdal facilitates seed deposits in the seed vault from the international community, as we've seen, of gene banks and research institutes holding seed collections of plant genetic resources, and is responsible for information and media visits to the vault. Attention was focused on the vault's vulnerability in May last year with the flooding of the entry tunnel triggered by permafrost melt, result of unusually high Arctic temperatures. This event, while no disaster ensued, highlights the vulnerability of this precious store cupboard. Rather less formally, I would say that I'm a great fan of headlines, and some of the headlines that this work has engendered have been quite attractive and striking. My particular favourite is the type of headline which you sometimes see in some of our popular press in this country, rather finger-pointing and accusatory. This man says this man does that. And the headline on the website Motherboard in respect of Dr. Asdal says, "This agronomist is safeguarding the world's seeds." Isn't that a wonderful headline to have written about yourself? Isn't it? And doesn't it explain in a nutshell exactly why we've invited Dr. Asdal to be our keynote speaker this morning? It's a very great pleasure now to hand over to him to deliver the keynote.
A very kind introduction, and thank you for inviting me to this conference. It's not working. Working better now? Yeah, good. Far much better. Thank you for inviting me to this conference, and we really appreciate to have this opportunity to explain about the mission of the Seed Vault. And I can assure you, as we have just seen this film, that it was a very touching moment to receive these seeds from these Peruvian farmers. And in fact, there are quite many of these touching occasions at the Seed Vault, because institutes, researchers, farmers, community seed banks, they're all very enthusiastic about this. So it's always a pleasure to receive seeds and guests at the Seed Vault. Here's my presentation. To begin with, just a couple of... there is some unintended animation here. Okay. Why I was so enthusiastic, inspired about seeds? I think seeds is... It's easy to get involved in seeds, and it's a good idea for this conference also to focus on seeds. And if you think seeds are the most important human food source, they are very nutritious, it's a perfect structure for survival of plants. It can be stored for the next season, it can be stored for long-term in gene banks. It's adapted to modern farming. Without seeds, we would have not been able to farm and produce food as we do. And some words, unfortunately, disappeared behind these pictures. But the point is, the natural mode of crossing of plants creating steadily new genotypes, new combination of genes is actually the precondition for farmers when they developed farming plants, crop plants from wild plants. You do not find the crop plants in nature, but you find the genes within wild plants, and that is what this is about. Today we eat mostly seeds from grasses having large seeds, and 60% of what we eat are actually seeds from these three plants. Some photos. I have, of course, a seed collection in my office, and I lent these seeds to one of the Norwegian the best nature photographers in Norway, and he made these very nice photos of the seeds. And it's easy to be fascinating about these structures, the diversity, the shapes, the colors, and carrots here, red beets. And if you are English, it's nice to see this football shape, Swede seeds related to the football match later today. I'm sorry about switching these slides, but there is something wrong with the animation here. But it's important to stress the difference between genetic diversity and biological diversity. Yesterday you heard about the Millennium Seed Bank conserving seeds of threatened species. We do not conserve seeds of threatened species. I often get the answers, do you have any threatened, any rare species in the seed vault? But actually we have not. We have rare, threatened genotypes of common species. So there are thousands of genotypes within these crop species in the seed vault. So we do not conserve species, we conserve genotypes, genetic combinations within species. So that is the difference between the Kew Garden Millennium Seed Bank project and what gene banks all over the world do, and what we do at the seed vault. So this illustrates the difference between, it illustrates the genetic diversity. Actually, here you see three wolves. On the left, you see the wild wolf, and on the right, you see two examples of dog breeds. So the genes for developing, creating these dogs are already present in the wild wolf. And that is exactly the same situation with seeds and plants. There is a huge crop diversity, genetic diversity within plants, beans, potatoes, carrots, barley. And this is an interesting example because the maize we produce and the maize we eat, it originates from this wild Tripsacum plant to the left on this small plant. So the genes for producing and developing maize is found within the wild Tripsacum plant in the Latin America. And for brassicas, on the Mediterranean shores, you find this wild brassica, and the genes for creating all these different edible vegetables from the brassicas can be found in the wild brassicas. Cabbage, Brussels sprout, kohlrabi, kale, broccoli, cauliflower. Genes for creating all these different vegetables are already inside this wild brassica. And then you start to realize how important it is to conserve this genetic variation. Producing wheat, the wheat plant we eat, it's the most important plant we have on Earth for food production. And the history behind wheat is quite extraordinary, because in the Middle East, where civilization started, in the wild you find emmer wheat and you find goat grass, and those two plants crossed occasionally in a farmer's field, and this farmer saw suddenly a new plant in his field, and it was the common wheat, which farmers then improved. They saved the best seeds, the seeds from the best plants the previous year. They collected the seeds. They used these seeds for sowing in the next year, and slowly, the wheat plant was improved. And at the left there, you see an English variety, more than 100 years old, and then 100 years later, we have this Shango, a new modern English variety. You can see by yourself that it's more high-yielding, the variety at the right, but the genes were there already in the wild plants, and breeders, farmers first, and then breeders were able to combine new combination of genes and produce these high-yielding cultivars and varieties. So farmers in the Middle East, they found wild barley. They started to cultivate them. They started to collect seeds, started agriculture, then they improved the varieties. So through 10,000 years, 10,000 years, the improvement of the varieties, improvement of crop plants were done by farmers. The last 100 years, scientists and plant breeders have continued this work with modern technologies and have been able to create new high-yielding cultivars that has increased the yield year by year, and now it's possible to feed a growing population because of the genes that were present in the wild plants, because of the work that farmers did through thousands of years. And we have to conserve these genes because breeders and scientists will need these genes also in the future. So this is the pioneer behind the gene bank movement. This is Nikolai Vavilov. He was born 130 years ago, and he traveled around the world. He discovered that he had the idea that we had to conserve these old varieties, also the wild relatives of these crop plants, because they had genes that were valuable for science and improvement of varieties. He traveled all around the world, collected seeds, and established the first gene bank in St. Petersburg in the 1920s. He also discovered these global centers for the origin of crop plants. And here you can see where the wild plants that are ancestors of the crops we eat originate from. You see potato from Peru. We just saw the film from Peru. They have the center for potato wild relatives. Maize in Mexico, and the most important place is number 4 there, which is the Fertile Crescent in the Middle East, where you find ancestors of barley, rye, wheat, and a lot of other plants. Vavilov established the first gene bank in St. Petersburg in Russia, and this gene bank is still existing and is still one of the most important gene banks in the world. Here is, I was able to sit in Vavilov's chair last November. It was a great moment for me. Without Vavilov's pioneer work, I would probably not been working with this project. We would probably not have a seed vault at this time. This is from the Nordic gene bank, which is a modern gene bank using freezer, stand-up freezer cupboard. This was established in 1979, and most gene banks in the world were established after the World War, 60s, 70s, and it is quite astonishing that Vavilov was so early and established this gene bank in St. Petersburg already in the 1920s, and this still exists. It was a kind of pilot for all gene banks all over the world later. So now we are approaching Svalbard. The Nordic Gene Bank was established in 1979, and it was already from the beginning quite important to find some kind of security measure to secure the seeds. It's always like that. Seeds and other items that are stored only in one place, it's vulnerable for disasters, for accidents, and so on. So the Nordic Gene Bank was able to put a steel container into a coal mine in Svalbard in 1984. And copies of the Nordic seed collection were placed in this steel container from 1984, and we still have this steel container there. Now our Nordic security copy collection is moved to the seed vault, but we still have seeds inside there because we run the so-called 100 Years project. In 1986, we took out seed, we put in seeds that in these boxes of 15 different species, 2 varieties of each species, and every 5 years we take out 1 box, test the seeds, and see how these seeds germinate after 5, 10, 15. And now this last year we took out seeds and tested them after 30 years of storage within permafrost in this coal mine, and we are just now writing the report about the results. And some seeds germinate as well as they did 30 years ago, but other species have declined in the germination ability. The history of the seed vault is that when FAO and other international bodies looked to this Nordic facility at the seed vault, they asked Norway, would it be possible to establish a secure seed vault, seed storage for copies from gene banks all over the world in Svalbard, not only for the Nordic seed, but also for global seeds. And the Nordic prime ministers, they launched we call it the foundation stone. It's stone and seeds, and this cylinder there. They announced the project in February in June 2006, and the seed vault was opened in 2008. So why Svalbard? I think the most important thing is that to be involved in the conservation of biological and genetic diversity is according to Norwegian commitments in national fora, and Norway was instrumental in the CBD in 1992, and after that Norway has been contributing to projects for conservation of biological diversity. Svalbard is a well-suited place because of the cold climate, permafrost. We have an airport quite close to the seed vault, so it's easy to go there. At the same time, it's a very remote place. You feel very safe when you're there. So there are a municipality and governmental presence there, police, all the infrastructure you need for running such a facility. And quite important, countries and gene banks trust that Norway will take good care of the seeds. This is a model of the seed vault. It's built in virgin rock. It's not in a coal mine. Many people think that it is placed inside a coal mine, but it's not. It's not the methane gases inside the seed vault, which would be could be harmful to the seeds. It's 130 meters above sea level. In case of sea level rise, the permafrost provides about 4 degrees minus. The seed vault is maintained artificially at minus 18 degrees inside, because that is the same temperature as gene banks use in their collections. There are surveillance systems. It was said here about, it was mentioned the flooding of the seed vault in 2016, and it is correct that temperatures in Svalbard has increased quite a lot, quite dramatically actually, the last 10 years. And the warm season, where you have free water on the surface, it has been more rain, and we had an incident in the autumn 2016 where water came into the tunnel and had to be pumped out. And last year, the decision was taken that it was needed to make the tunnel completely watertight, also when we do not have stable permafrost in the upper layers. So now construction improvements are taking place and will be finished next summer. And actually the Norwegian government is spending 200 million Norwegian kroner, which is 20 million pounds on this project, to create a completely watertight construction, safe also for the future. This is the organization behind. It's owned by the Norwegian government. The Global Crop Diversity Trust, you saw some glimpse of them in the film. They are partly funding the seed vault management project. I'm representing Norgen, which is responsible for the management. Statsbygg is responsible for the facility itself, and we have an international advisory panel overseeing the operations and anchoring the operations in the international community. The conditions for storing seeds in the seed vault, it's free of charge. Norway is taking the responsibility for the costs. The gene banks has to cover the shipments, but to have seeds stored in the seed vault is totally free. The seed banks that send the seeds, they still own the seeds. Seeds can only be returned to the owner. And seeds should be available for breeding, research, and education. And that's why private companies normally not want to place the seeds in the seed vault, because we require that the seeds and the genetic codes and the genetic resources should be available for breeding. So in this, by having this requirement, the seed vault project also contributes to keeping genetic resources in the public domain and preventing genetic resources from being privatized. It's also required that the seeds are secured in a primary gene bank, in a secondary gene bank, and Svalbard should be the third place to have these copies. So the seeds are very safe. We are often asked, how do you know how long these seeds stay viable in the seed vault? And we do not do any testing of the seeds in the seed vault. It's the responsibility of the gene bank that sent the seeds, because they have the same seeds in their gene banks. They test the seeds regularly, and when they see that now the seeds need to be replaced by new seeds, they also send new samples to the seed vault. So this is some pictures from what is happening in gene banks. Seeds are dried. They are packed in such envelopes like this, and packed in boxes, and sent in these standard boxes to Svalbard, brought up to the seed vault entrance, put into we bring them into the first hall there. We put some on labels. We have accession lists. All gene banks have to provide lists showing all accessions, all seed samples that they send to the seed vault. So at any time we know exactly which gene banks sent which seed samples, what are the names of we call them accessions, the seed samples, in what boxes are they placed. They could be found at any time and sent back if needed. And we put them in the shelves like this, and it's quite ordinary storage when you see it, but when you are in there, you really feel that this is kind of a mission for the world's future. So it's a huge difference between the simple construction and the feeling and the mission and the objectives of the project. So at the moment, there more than 1 million samples have been deposited in the seed vault. At one occasion, ICARDA has requested seeds back. You may know about, of course you know about the civil war in Syria, and ICARDA, which is the International Center for Agricultural Research in dry areas, had its gene bank and headquarters in Aleppo, outside Aleppo in Syria. And this gene bank was partly destroyed, partly inaccessible for the scientists, and they decided to establish new gene banks in Lebanon and Morocco, and they requested seeds back from the seed vault. And it's of course a disaster what happened in Syria, but at the same time it showed that having a seed vault security facility like this is really needed. And it's not a doomsday vault meant for being used in the far future. It's a part of an active international system for taking care of seeds working just now and in active use. 968,000 samples are currently stored in the seed vault from more than 5,000 species. And at the moment, 76 depository institutes have deposited seeds in the seed vault. And it's important to say that these are copies of the seeds that they have in gene banks. And we deliberately do not call the seed vault a seed bank, because a seed bank, they produce seeds, they distribute seeds, they do investigations on the properties in the seeds and the varieties, they do breeding work, a lot of stuff. The seed vault has nothing of this. We do not do any testing, produce no seeds. We just bring seeds in and out and keep track of what seeds we have there. So that's why it's not correct to call it a seed bank. This is the 20 crops that are best represented in the seed vault. At the moment, we have more than 160,000 genotypes of wheat, more than almost 160,000 genotypes of rice, 70,000, almost 80,000 of barley, then 50,000 sorghum, then beans, maize, vigna beans, soybeans, and you see the other crops. So the main crops are quite well represented, and for some of the crops we feel that we almost have conserved in the seed vault the total genetic variation we have in these crops. But some other crops are not that well represented, and we still work on encouraging gene banks to send copies of their seeds and to secure it all in the vault. So this is showing the development of the increase of seed samples in the vault, and it's showing that steadily new gene banks and new seed samples. So the interest for depositing seeds in the seed vault has been quite stable, increasing, and it's quite popular actually to send seeds to the seed vault. When we have state visits to Norway, the president, the prime minister or something, a delegation, they often want to bring seeds to the seed vault and have that as a kind of event when they are in Norway. And we appreciate that. The seed vault has actually two main purposes. The first is to protect the seeds, but the second one, maybe as important as the first one, is to increase the public awareness about conservation of seeds and conservation of genetic resources. So the seed vault has actually been a quite iconic symbol of the importance of taking care of genetic resources, and that is very important too. So when a prime minister, a president comes to Norway, want to bring seeds, he also brings press. We have newspaper articles in his country, and people all over the world are being more and more aware of the seed vault and also aware of the importance. Some more, I included some slides also about the potato seeds from Parque de la Papa in Peru. You just saw the film. This is a community of Quechua people producing seeds in the Andean mountains. And the history was not fully explained in the film. Previously, they used local varieties, these farmers in the Andean mountain, and slowly they started to grow modern varieties. But they also faced climate change varieties back from the potato center in Peru, SIP, which is one of these international centers having large gene banks. And they started to produce their old varieties and discovered that these yielded better than the modern varieties. And then they started to plan this project for bringing the seeds to Svalbard. They made a kind of private organization, idealistic gene bank in Parque de la Papa, and they decided to deposit copies in the seed vault. And it was actually a quite touching moment when they went there. You saw the film. So at the moment they have 70, this is a kind of a picture from our database. You can anytime look up our website and see how many samples, which species, which gene banks. And this is some details from this gene bank, Parque de la Papa. They have 750 seed pouches, 62,000 seeds. In one seed box, 6 different Solanum species, potato species, 5 species and 6 taxa. And they also made this blessing of the Icada seeds. Actually, this was the day before we brought out the first seeds back to Icada, a new Icada gene bank, the seeds that were lost in Aleppo. So it was quite a touching moment, this too. And the first UK seeds arrived in 2017, also that potato seeds. We hope that more seeds from UK will arrive soon, and these are the seeds from the Commonwealth Potato Collection at James Hutton Institute. I think it's in Scotland. They arrived in 2017. And one of the last slides showing the diversity of seed boxes in the seed vault. We just give some maximum size measures of what boxes can be used. And you see boxes here from many different countries. And we have boxes from Russia, from Ukraine, side by side in the seed vault. We have boxes from the United States and North Korea, quite close, and South and North Korea are very close. So I think someone claims that reconciliation between those two Korean countries started this year, but actually this started in the seed vault about 5 years ago. So that's it.
Thank you so much for that wonderful presentation.